So I'm going to show you another example of the airplane and its wind. And we'll try number 81 in class when I see you on Thursday, okay? So you guys, as I was saying, here's the airplane right now, but there's this wind, and the wind is pushing this airplane over here. And now it's here. So that means our speed is going to change, right? Our speed will change, and also our direction. So we'll have to find both of those. But remember, there's V1 because that's the actual speed of the airplane at the moment, okay? But it also has a horizontal and a vertical component, okay? So this one we'll call it V of X and V of Y. Now we have the wind. The wind itself has a 70 mile per hour direction. Make sure you guys read over this question first, okay? So stop the video right now and read over the question. All right, welcome back. Now it's here, it's 70 miles per hour, so I'll write the 70 here. Remember I told you, velocity and speed is always referring to the magnitude, okay? And here, this resultant, right, this original plane's velocity is actually 500. So write 500 there. But remember, it's the magnitude, okay? It's 500 here. So it's a magnitude, okay? But remember, this wind here, it also has a vertical and horizontal. The vertical is here, and the horizontal component is here. And you guys, let's call this guy V2. And this guy we'll call U sub X, and we'll call this guy U sub Y. Okay, because it's the horizontal component of the wind, and this is the vertical component of the wind, U sub Y. So, but, you guys, I just want you to recognize something. This is the resultant of the airplane after it's been pushed by the wind, right? So that's called the resultant, so we'll write resultant here. And we'll call that vector, let's call it big V. V, okay? So V is actually equal to, right? The resultant is equal to the vector V1 plus vector V2. This is the plane, and this is the wind. Does that make sense? Okay, so we're going to have to add the horizontal components. So that means, you guys, watch. V is actually the component, because we don't know the vector of the resultant, right? V. That means we have to add the horizontal components of V of X plus U of X and the vertical components, V of Y plus U of Y. Okay, that's what we're going to do. And that's what we have to find. So you remember how that's the plane? So let's do the plane first. The airplane, okay? Let's do the airplane. So you guys, V sub X, and we have to find V sub Y. What is that going to equal? But remember, they told you that this is 120. That means this is actually 60 here. But you guys, let's actually just use 120, not the reference angle, okay? So you know that cosine of 120 is going to equal V sub X over 500. So that means V sub X is going to equal 500 cosine of 120. And that likely sine of 120 is going to equal V sub Y over 500. Because it's V sub Y opposite, remember this angle here, opposite over hypotenuse. That's going to be 500 sine 120. And if you've seen the pattern, it's always that kind of case, okay? So we have that, okay? Now let's actually find the vector of that guy, okay? Remember, this is guy, yeah, we're going to have to add the actual vertical components and the horizontal components. We have this, but we don't actually know the values, right? So I'm going to actually compute it all the way. So I'll actually do it here. So you guys, this guy actually equals negative 250, okay? This guy is actually 250 root 3, and that's because cosine of sine of 120, you guys already know that, okay? Those are special right angles, right? So now, after we put this into vertex form, it's going to become, so that means the plane's vertex V1 vector is going to be negative 250 and 250 root 3. Those are our vector for the plane. Okay, that's what that guy is right there, okay? Now let's do the wind. The wind, you know it's going to be U sub X and U sub Y. We have to find those. Same thing. Isn't this angle given as 45 degrees northeast? That's 45 degrees, right? So we do. I mean, you guessed it, right? It's going to be what? 70, because that's the wind, right? That's the wind speed. And it's going to be cosine of 45 degrees, and it's going to be 70 sine of 45 degrees. Check that out. And that's because it's going to be, because cosine of 45 degrees is the opposite sine, right? U sub, it doesn't matter because it's a 45-45 triangle, is going to be U sub Y over 70. And cosine of 45 is going to equal U sub X over 70 degrees. And that's how we change the equation, okay? So those values are actually 35 over root 2, and this one is also 35 over root 2. All right? But, we forgot something here, huh? This is actually negative, right? Because it's actually not 45, right? This 45 is a little bit confusing because actually, oh, it is 45. It is 45. I'm sorry. This is actually right. Sorry. Okay? So now we have vector 1, vector 2, which is actually 35 over root 2 and 35 over root 2. And that's our vector 2. Okay? Now what do? It says here we have to add them together, right? That's how we get the resultant vector. Okay? So we add those together. So I go V. I'm actually going to do it on a separate sheet. So guys, make sure you guys go back to that, okay? So you guys, our V is equal to V1 plus V2, right? So we have those values now. So our vector is going to be negative 250 plus 35 over root 2, comma, because that's from each of the horizontal and vertical vectors, 250 root 3 plus 35 over root 2. And when I actually compute that, you guys, I get something like this, negative 200.5 and 482.5. So I shortened it here, but make sure you guys keep the original values of your calculator, okay? This is our resultant vector. So you guys, let me show you the picture again. That means this is a coordinate for this guy here. This guy, the resultant. This resultant. This resultant now has a vector, okay? All right, now, what do we do with that? Well, they want us to find the actual resultant vector, the plane's speed now after the wind. So we got to find the magnitude of that. So I get negative 200.5 squared plus 482.5 squared. And you should get something like 522.5 miles per hour. So now the plane is flying 520.5 miles per hour. With the wind, it's being helped, right? Because it used to be 500 miles per hour. Now they want us to find the direction angle. Okay? And that's just tangent. Theta is equal to B over A. But our B is here, our A is here, so we get, so I'm going to do this, you guys. Arc tangent, right, of 482.5 over negative 200.5. Okay, because we're looking for the angle. So I get about negative 67.435 degrees. Negative though, but you guys, you know you can't be negative, so you have to look at the coordinate here. It's negative this much, right? This is the angle here. That means we have to go to the opposite side, so we have to add 180. Because this is our direction angle. You know what we're looking for? We're looking for the direction angle, which is here. Okay, it touches the resultant, right? That's the direction angle looking for. Okay, so now let's go back. It's that. So what are you going to do? You're going to add 180. So you're going to add 180 degrees to this, 180 degrees to that, and you get theta is, our direction theta is actually 112.6 degrees. Okay? Our direction angle, which is this right here. Okay, that's what we're looking for because we have the plane here and it's going, the plane used to be here but now it's here, right? Remember the picture? That's our direction angle. Okay, good luck. I know it's pretty hard. Bye.